Hello students, today we are going to start the Z transform, its properties and the region of conversion. What is meant by the region of conversion? The region of conversion is the range of complex variable Z in the Z plane. The Z transform of the signal is finite or convergent. So the ROC represents those set of the values of Z for which x of Z has a finite value. Properties of the region of convergence. So the properties of the ROC depends upon the nature of the signal, assuming that the signal has the finite amplitude and that the Z transform is the rational function. So suppose the first property is the ROC, that is ROC is a ring or disk in the Z plane centered at the origin, and it should be greater than 0 but less than infinity. So the ROC is nothing but the first property is the ROC is nothing but the ring or disk in the Z plane centered on the origin, that is R is greater than or equal to 0 but less than mod of Z, and mod of Z is less than the R of L less than equal to infinity. So this is the first property. So the region of conversion should be lie between the 0 to the infinity. The Fourier transform of the x of n converges the absolutely if and only if the ROC of the Z transform includes the unit circle. So if the Z transform or ROC includes the unit circle, then the Fourier transform of x of n converges absolutely. ROC cannot contain any poles. So in the region of conversion, there is a no pole lie in that ROC. If the x of n is a finite duration, that is minus infinity to the infinity, except 0 except on the finite interval, then the ROC is the entire Z plane except the perhaps Z is equal to 0 or Z is equal to infinity. Suppose if your sequence is the finite duration, so ROC is your entire plane except Z is equal to 0 and Z is equal to infinity. So this is the fourth property. If the x of n is the right-sided sequence, then the ROC extends towards the outward from the outermost finite pole to the infinity. So you already checked this right-sided sequence. In right-sided sequence, ROC extends from the outward from the outermost finite pole to the infinity. And in case of the left-handed sequence, that is x of n is the left-handed side, then the ROC extends towards the inward from the innermost non-zero pole to the z is equal to 0. And in case of the two-sided sequence, that is neither left nor right-sided, has the ROC consisting of a ring in the z plane and bounded in on the interior and exterior by the pole and not containing any poles, and the ROC is connected to the region. So these are some properties of the ROC. Let us take the signals and their ROC. Suppose delta of n, that is the impulse signal, is there is Z transform is 1 and the ROC is entire Z plane. If your sequence is u of n, then the Z transform is 1 divided by 1 minus Z raised to minus 1, and its ROC is mod of Z is greater than 1. So these signals and their ROC is useful while solving the examples. If your sequence is right sided, that is a raised to n u of n, right sided exponential, then its ROC is 1 divided by 1 minus a into z raised to minus 1, and its ROC is mod of z is greater than mod of a. If your sequence is left hand side is exponential, that is minus a raised to n u of minus n minus 1, then its z transform is 1 divided by 1 minus a into z raised to minus 1, but the ROC is different, that is mod of z is less than mod of a. So this is the change in this. If the transform is same but the ROC is different, if the signal is n a raised to n u of n, then its z transform is a into z raised to minus 1 divided by 1 minus a into z raised to minus 1 bracket square. So its ROC is mod of z is greater than mod of a, and its sequence is minus a raised to n u of minus 1, n minus 1. Then z transform is a into z raised to minus 1 divided by 1 minus a into z raised to minus 1 bracket square, and its ROC is mod of z is less than mod of a. If your sequence is u of n into cos of omega n, then ROC Z transform is Z square minus Z cos omega divided by Z square minus 2Z cos omega plus 1, and the ROC is mod of Z is greater than 1. And if the sequence is u of n sin omega n, then the Z transform is Z sin omega divided by Z square minus 2Z cos omega plus 1, and the ROC is the mod of Z is greater than 1. So these are the some signals and their ROC. So let us take one example. Suppose sequence is x of n is equal to 7, 3, 4, 9, 5, and the origin is lies where the origin of the series is at 3. So 3 is the 0 is at lies at the 3, or origin is lies at the 3. So applying the Z transform, so Z transform x of Z is equal to summation minus infinity to infinity x of n Z raised to minus n. So the sequence is from the minus 1 to the 3. So the your summation shall become n is equal to minus 1 to the 3 x of n Z raised to minus n. So apply the Z transform, minus 1 Z raised to 1, x of 0 Z raised to 0, x of 1 Z raised to minus 1, plus x of 2 Z raised to minus 2, plus x of 3 Z raised to minus 3. So it becomes, so at the minus 1, so it is a 7, x of 0 it is a 3, x of 1 it is 4, x of 2 it is 9, and x of 3 it is 5. So the ROC is the entire Z plane excluding Z is equal to 0, infinity and minus infinity. So let us check out the some properties of the Z transform. The first property, that is linearity. It states that when two or more individual discrete signals are multiplied by the constants, their respective Z transform will also multiply by the same constants. So that is a1 x1 of n plus a2 x2 of n. These are the two sequence and constants are a1 and a2. Then its Z transform is same, that is x1 of z and x2 of z, and multiplied by the same constant a1 and a2. So it becomes a1 x1 of n plus a2 x2 of n, that is equal to a1 x1 of z plus a2 x2 of z. So proof, that is x of z, use the formula x of z is equal to summation minus infinity to infinity x of n z raised to minus n. So summation n is equal to minus infinity to infinity a1 x1 of n plus a2 x2 of n z raised to minus n. Multiply the z raised to minus n into the bracket. So you will get this step, a1 summation sin x1 of n z raised to minus n plus a2 summation x2 of n z raised to minus n. So you will get the a1 x1 of z plus a2 x2 of z. Here the ROC, that is the ROC intersect with the ROC2. Time shifting, second property. The time shifting property depicts how the change in the time domain in the discrete signal will affect the z domain, which can be written as a x of n minus n0, that is sequence is delayed by the n0 samples. Then its z transform will become x of z into z raised to minus n, or x of n minus 1 is transformed to z raised to minus 1 x of z. So let us derive this property, that is y of p is equal to x of p minus k. So y of z becomes summation p is equal to minus infinity to infinity y of p z raised to minus n, that is equal to y of p is nothing but the x of p minus k. So that is x of p minus k into z raised to minus k. So let s is equal to p minus k. So replace that term. So summation s is equal to minus infinity to infinity x of s z raised to minus s plus k. So that is equal to, divide this bracket, indexed bracket. So x of s into z raised to minus s, z raised to minus k. So take out the z raised to minus k outside the bracket. So summation s is equal to minus infinity to infinity x of n z raised to minus n. So hence proof, that is z raised to minus k x of z. So the ROC is written as a z is equal to 0, p is greater than 0, or z is equal to infinity, p is less than 0. Let us take the one example, u of n and u of minus n minus 1. So this is the u of n and u of n minus 1. So the z transform of u of n can be written as a summation minus infinity to infinity u of n z raised to minus n, which is equal to the 1. So because unit step function. And the z transform of u of n minus 1, it is summation u of n minus 1 z raised to minus n is equal to z raised to minus n. So hence proves that is x of n minus 0 is equal to z raised to minus n x of z. Time scaling. The scaling property tells us what will be the z transform of the signal when the time is scaled in its discrete form, and which can be written as a raised to n x of n, that is transformed after the z transform x of a raised to minus n into z. So let us derive this property y of p is equal to a raised to p x of p. So your y of p z transform is summation p is equal to minus infinity to infinity y of p z raised to minus p. So that is p is equal to minus infinity to infinity a raised to p x of p z raised to minus p. That is equal to summation p is equal to minus infinity to infinity. Take x of p outside and combine the index of a and z. So a raised to minus n z raised to minus p. So this becomes x of a raised to minus 1 z. So the ROC is the mod of a into R1 less than mod of z less than mod of a into R2, where mod is nothing but the modulus. So hence true. Let us take the one example. So sequence is x of n is equal to a raised to n cos of omega n using the time scaling property. So cos of omega n, that is the summation n is equal to infinity minus infinity to the infinity cos of omega n z raised to minus n. So it's as per the table, its output will become z square minus z cos omega divided by z square minus 2z cos omega plus 1. So applying the time scaling property, so a raised to n cos of omega n z raised to minus n, so it becomes x of z raised a raised to minus n z. So it becomes z into z minus a into cos omega divided by z square minus 2az cos omega plus a square. So simply multiplying the a to the coefficients of cos. So successive derivation, differentiation. The successive differentiation property shows that the Z transform will take place when the differentiate the discrete signal in time domain with respect to the with respect to time. So it can be shown as a d of x by n divided by d of n is equal to 1 minus z raised to minus n x of z. So let us consider the left hand side d of x of n divided by d of n. So that is x of n minus x of n minus 1 divided by n minus divided by n minus of n minus 1. So it becomes x of n minus x of n minus 1. So it becomes x of n is represented as x of z, and this represented by the minus 1 is, that means z raised to minus 1 x of z. So it becomes 1 minus z raised to minus 1 into x of z. So hence 2, and its ROC is the R1 is less than mod of z is less than R2. Convolution. This is nothing but the change in z domain of the system when convolution takes place in the discrete time signal, which can be written as a multiplication at the z transformed signal. So x1 convolved with the x2 of n, so its convolution becomes the multiplication of the z domain signal, that is x1 of z into the x2 of z. So let us prove this property. X of z is equal to summation minus infinity to infinity x of n z raised to minus n. So that is summation minus infinity to infinity summation k is equal to minus infinity to infinity x of k into x1 of k into x2 of n minus k z raised to minus n. Multiply the z raised to minus 1 into the bracket, and outside the set x1 of n, so summation k is equal to minus infinity to infinity x1 of k, and summation n is equal to minus infinity to infinity x2 of n minus k into z raised to minus n minus k into z raised to minus k. So let n minus k is equal to L, then the above equation can be written as x of z is equal to k is equal to minus infinity to infinity x1 of k into z raised to minus k summation L is equal to minus infinity to infinity x2 of L z raised to minus L. That is equal to k is equal to minus infinity to infinity x1 of k into x2 of z into z raised to minus k. So that becomes x2 of z into summation minus infinity to infinity x1 of z z raised to minus k. So that is nothing but this term is nothing but the x2 of z. So hence true. And the ROC intersect with the ROC2. Initial value theorem. If the x of n is a causal sequence which has its z transform as a x of z, then the initial value theorem written as a x of n at the n is equal to 0 is equal to limit z tends to infinity x of z. So that is nothing but, you know, the x of z is equal to summation n is equal to 0 to infinity x of n z raised to minus n. So you can expand this series, that is x of 0 z raised to 0 plus x of n z raised to minus 1 plus x of t z raised to minus 2. Similarly for the negative term, that is x of 0 into 1 x of 1 into z raised to minus 1 plus x of 2 z raised to minus 2. So in this case, if z tends to infinity, z raised to minus n tends to 0, and this because n is greater than 0, so we can say that limit z tends to infinity of in z transform, so you will get the x of 0. Hence proof. Final value theorem. Final value theorem states that if the z transform of the signal is represented as a x of z and the poles are all inside the circle, then its final value is denoted by x of n or x of infinity, and can be written as a x of infinity is equal to limit n tends to infinity x of n, that is indicate limit z tends to 1 x of z into 1 minus z raised to minus 1. So the condition are, it is applicable only for the causal sequence, and x of z and 1 minus z raised to minus 1 should have the pole inside the unit circle in the z plane. So you can prove this property, that is z plus, that is positive infinity x of n plus 1 minus x of n, limit k tends to infinity, summation n is equal to 0 to k z raised to minus n x of n plus 1 minus x of n. So we can expand this series like this. So here apply the advanced property of one-sided z transform, so that the above equation can be written as a z of x plus x of n plus 1, that is equal to z of x of 2 minus x of 0 z raised to 0, that is equal to z of x of z minus x of 0, and by putting z is equal to 0 in above equation, so equation will become limit k tends to infinity x of n minus x of 0 plus x of 6 minus x of 1 plus x of 3 minus x of 2, and likewise. So 1 minus 0, 6 minus 1, 3 minus 2, like this. So above that equation can be formulated as a x of infinity is equal to limit n tends to infinity of x of n, then limit z tends to 1, that is x of z 1 minus z raised to minus 1. Differentiation in frequency, it gives the change in z domain of the signal when its discrete signal is differentiated with respect to the time. So nx of n is equal to minus z dx of z divided by dz, and the ROC is R2 is less than mod of z less than R1. Multiplication in time domain, if the input signal, that is time domain signal, is multiplied, its z transform will become 1 by 2 pi j into convolution of the two both signal in z domain, that is x1 of z convolved with the x2 of z. Conjunction in the time, this is representation of the conjugated discrete signal in the z domain, that is if complex x of n is there Z transform is also Z transformed signal is also complex conjugate. Thank you.